Hi everyone. Welcome to this talk about infrastructure drift, infrastructure as code, DevSecOps, and in the end, drift CTL, drift control. In this talk, I will briefly define what is infrastructure drift, what we learned the hard way, and then it's gonna be quickly more live, fun demos and stories. This will be a very hands-on talk if you wonder. Thanks for attending. So basically, last year we were working on a GitOps platform to support infrastructure as code and all the tooling and all the best practices, etc. And at some point, we needed feedback. We looked for a lot of feedback to build the next features. And basically, we went on to interview our users, and so we talked to a lot of DevOps, SREs, CTOs, etc. And the most important pain those people reported was definitely around infrastructure drift, the visibility of what's living outside of your Terraform configurations. So if you have only one thing to remember from this talk, it's that almost everyone experienced infrastructure drift recently, and that drifts can have major consequences, including security. And in the end, that's the reason why we built this open source tool called Drift Control, Drift Cuddle, Drift CTL. So I'm Stephane Jourdan, as Jourdan pretty much everywhere on the internet. I've been around infrastructures for the past 20 years. I co-founded a bunch of companies in Canada and Europe. And well, some years ago now, I co-wrote this book named Infrastructure as Code Cookbook, and more recently, I'm the happy co-founder at CloudSkiff, and we build the open source tool DriftCTL, and we have a great team at CloudSkiff. I'm so happy. So after talking to hundreds of people, we had to come up with a common definition of what is infrastructure drift. And basically, it's what happens when the reality and the expectations basically don't match. It's also known as, oh my God, when things definitely go wrong when they should not. So according to this definition, your AWS account has a ton of actual resources that's on the right, and maybe only part of it is correctly managed by Terraform, and that's the left part of this slide. And basically the diff between the two, the diff is the drift. So what are the causes of drift? There are many, but the major ones are basically the manual changes that you do directly on the AWS console when you log in and change some stuff. The authenticated lambdas, microservices, or maybe all those scripts that you run every night to snapshot the disks on AWS, or maybe you have something that scans for tags and do something else, etc. They are all authenticated stuff. There can be also this other team working with, another tool, different one than the one you're using, or maybe you have this AWS service not yet available in the current Terraform provider version that you have, so you have to use different tool, or maybe it can just be, that new project starting on this new cloud provider, different from the current one that you're used to. Obviously, no time to automate it properly. So all those activities and many others are all authenticated, and they are definitely sources, causes of drift. So it could be no big deal, and maybe we could all live for a long time with those drifts. But the problem is that misconfiguration can lead to security issues that you don't even know about. And we see here on this slide from the NSA that they recently labeled poor access control and misconfigurations as top issues, and not sophisticated either. So definitely you want to know about the unknown stuff running in your cloud provider's account. So as I just said, you definitely need to shed some light on all the unknown resources of your accounts, and those resources are not under control with Terraform, and only then you will know about misconfiguration, and only then you will be able to address or fix the issues. So what about the stories? I promised some stories at the beginning of the talk, and I'll now share a couple of them, 3, 4, depending on the time. And disclaimer, they are simplified for the talk, otherwise it will take hours to explain all the context, etc. But they are all from directly us, or our own experience, or our close environments. And I'll show as well how our open source answer, driftctl, drift control, helps discovering all the discrepancies in all the drifts for those users. So here we are. This is a first story of an authenticated microservice. The team, they basically shipped a new version of the microservice, and like on a Friday evening or something, and basically during the weekend something bad happened, and the on-call team, they looked at what could be wrong, and they looked here and there, and basically what they did in this case, so it's what's on the slide here, they looked at many options, including the Terraform. So let's take a look here what it looks like, and here we are. So if you are not familiar with Terraform, very quickly, Terraform 101 primer in 2 seconds. That is a resource. It's creating an IAM user on your AWS account with the name tags. This is another resource. This is creating an access key, and this is linked to the microservice user, the IAM user here, and this is a policy attachment directly to this user. So basically what this code, very simple code, does is creating a dedicated IAM user here. It's creating an access key, and it's attaching a policy, read-only policy, to this user directly, this microservice user. Very easy. So basically the team, the on-call team, during the night between that Friday and Saturday, they decided that maybe it was a problem of a matter of I don't know, keys. Why not? So they decided to rotate the key. So they deactivated the old one, the one that was managed by Terraform, and they created a new one here. And basically they checked around what was working or not, and discovered that didn't change anything. So they said, okay, it's probably the permissions, like the read-only permission here is probably the issue. So let's add a much better one. So it wasn't administrative access, to be honest, but it's quicker for the demo here. So now you have and obviously it didn't change anything for them, but now they had an IAM user with rogue keys running here and there, copy pasted, I don't know where, and those keys had a nearly administrative access on the AWS account. That's what they did. And they said, okay, well, we'll tell the guys on Monday or something, and anyway, it's all on Terraform, so it can't be missed, something done like this. And basically what happened is that indeed everything was on using Terraform. And so the guys on Monday obviously forgot to tell about the change the team, and the team, well, just Terraform applied here and there along the day and didn't see anything. Zero added, zero change, zero destroyed. So what it means here is that you can, the way they wrote it, they couldn't get the change out of Terraform scope. The scope of Terraform in this case was only what was described, and the state couldn't know that an attachment, which is outside of its scope, could be a drift, or at least in this case a major change. And basically, if they had used driftctl in this case, so how does the driftctl work? You use the keyword scan, you give it a lot of states. So in this demo, we're going to have an IAM, a VPC, and S3 examples. And basically, you give them, you give the tool a lot of states. So it can be 100 of states directly on S3 or something. We are scanning, and you will see here that there is a key for the microservice. And that is definitely not covered by Terraform. So this is a problem. So that's for well, another thing while we are at it. Another thing that driftctl does is create a kind of a coverage percentage, like how much of your cloud infrastructure is covered, and so you have a different information like deleted resources, change resources, that kind of things. So, all right, so let's go back here, and basically, unfortunately for them, that microservice continued to run like this for weeks until someone completely by chance checked the credentials and said, what is that? So that's the oh my god effect from a few slides ago. So that was a first example. A second story is that at the beginning, of the pandemic, like more than a year ago now, people started to work from home, obviously, and a couple of them in the team couldn't connect to the company network for some reason. They tried to contact IT, blah, 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 it didn't work. So they were upset, and they just called on the phone some managers here and there to do something. You probably know that situation very well. And problem is that one of them had enough credentials to log in to the web console, the AWS web console, and do some changes on the network. So basically, what happened here, so the screenshot is good. Let me share the actual code here. All right. So basically what happened here is that this is still a security group resource, and the way it's written, you do not have the ingress and egress blocks directly inside the resource for good and bad reasons. So this team created rules separately. That's another way of doing things. And they attached the rule, so allowing TCP, SSH, TCP/22 only for the local network. So it was good. Only you could access the instances, the machines, only from the local network. So good. So what our managers could do? So they could log in here directly on the web console. They found the super secure security group, and they said, okay, my guys need to work. I don't care about anything else. I really need everyone to work. So let's allow just to check. We'll see tomorrow. I tell the IT that I did that. So all traffic from anywhere, IPv6, IPv4, I don't care about the IDs. And well, let's call this temp. You know, the temp rule, very useful description. So, and the guy, the manager that did this with the good credentials, he was pretty sure that he was about to tell the infra team, you know, the DevOps guys. And then the day after, problem is the day after he had a lot of meetings, etc., etc. He completely forgot. So what happened? Fortunately, this team had a Terraform plan and apply in like a recurring task on CI, and basically they were pretty sure as well that if you Terraform applied that kind of situation, they would know about it. Sorry, and thing is, too bad. 0 added, 0 change, and 0 destroyed. In this situation, once again, Terraform cannot know about the change for a very good reason, and the reason is that an attachment is an attachment. It's not an inside block. It's not seen as a single resource. And if you add a new resource, it's just basically a different resource for Terraform, and Terraform cannot know about it. So you can add hundreds of resource rules like this, and it will never be seen. So basically, once again, if we check what driftctl would have seen in this case, it's scanning the resources in the account, and now it can say, okay, I compared all your Terraform states combined, and I compared with what I found on the AWS account, and I found rules for this security group ID, and they are type ingress, and they allow pretty much everything, pretty much for everyone. So people who'd have known about it had they used such a tool in their CI/CD, I don't know, every hour or every night or something. Problem is, as I said, in this case, the manager in question forgot to tell the team, and basically, as everything was solved, no one cared anymore about talking to anyone, about using tickets or whatever, and it was solved. It was a solved issue, and for weeks that security group was opened, fully opened to the world. So fortunately for them, nothing bad happened, but I have a very similar story that happened to a close team of mine like a few weeks ago, and major problem happened in this case. Just to share the story, it was an RDS using PostgreSQL, and basically the port 5432 was opened to an IP address that was the outgoing IP from for the company, and basically they had a pen testing test for a customer, and unfortunately for them, the pen tester could access the database, and he wasn't happy about that at all, just because a developer one day, months ago, added the company IP to access directly the database for it was easier for him. You know, that's the kind of stories we had recently. A quick one. This one is a lot of fun because it's a team in they were in London. There were like 100 of developers. They were building a plugin, and every hour or so, they uploaded a temporary build of the plugin to an S3 bucket, and from there, some QA and testing started, and then everything was wiped and everything was deleted. So usage was extremely temporary. And basically, they had a very simple S3 bucket. You can see here, you have the resource. It's very, very simple. They wrote it that way, the simplest way possible. And at some point, another team from the same company, they had a compliance roadmap, and they decided to check every single S3 bucket in use in the company to add them a lot of things, including versioning, object versioning. And so they meet at some point, and the team I was working with, they told them, well, we do not need, we should not enable S3 versioning in this specific case, just because, as I told you, that this will cost a lot of money for absolutely nothing. Everything is getting deleted all the time, etc. So the other team said, okay, cool, thanks for telling us, we will not do it. And they came back and started to work on their own script to enable it everywhere. So it was using Bodo in Python, and they had a lot of tests, they had a lot of things, plus an exclusion list that was about to work. And the team I was working with had the Terraform in place, and they were pretty sure that anyway, if something bad was to happen, they would know about it. Because they were using Terraform. So what happened? So actually, it was using directly the API using Bodo in Python, but in this case, for a more visual way of doing it, what they did is basically just enable versioning here. So let me. So they enabled versioning here. Save changes. All right, so now it's done. Very happy about that. And what would driftctl in this case see? driftctl would report that the bucket DevOps Pro EU demo blah 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 as an S3 bucket in Terraform, meaning had this setting changed from false to true. Versioning was enabled because basically the script from the other team failed to run properly. The exclusion list never worked, and they never thought that it could not work. And the team I knew never thought that their own Terraform plan and apply in CI and at each and every hour or so would not see either the change. Because if you go to S3 and you Terraform apply, what's going on now? I think you probably guessed now. Nothing. All right. So that's the kind of things that happen in real life. For the fun story, monitoring and in this team was like the billing department, finance at the end of the first week and the month after they received the bill, and they said, "Oh my God, what is this bill?" So that's monitoring by billing, not the best monitoring. So what can you do with such a tool like driftctl? You can integrate it in all your own tooling. The goal here is to integrate all the data that drift control can output. So you can integrate it with a different tool. Maybe you can store the data in the database for dashboarding, like a lot of stuff. So you can use the JSON output. So in this case, you can just -- output JSON blah 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 and see directly the JSON. And you can use a tool like JQ, for example, to parse the output and do whatever you want with that. So I personally like to extract coverage here. So this is 75 in this case. I really like manipulating the strings, very easy using the outputs. The JSON output from driftctl. We have filters as well. So for those of you who are already familiar with the AWS CLI, it's using JMSPath. So it's a query language for JSON, very well documented. So if you would like to report only for a certain type of resources, I don't know, maybe just a tag like environment is production, or anything specific to your case, like only IAM users, keys, I don't know, what do you want? You can do whatever you want with precisely those filters. So it's very powerful, it's very useful for analyzing or reporting on just very specific areas. So in the example here, it's just reporting on rules that changed. So probably you don't want to scan your whole account every hour or so for any type of change. Maybe if you have bigger accounts, AWS accounts, maybe you want to have some focused checks in this case. We also have a drift ignore. So the drift ignore, if you start, if you're just getting started with your with an existing account, you probably have a lot of unmanaged resources in your AWS account, and even if you have 70% of your account in Terraform, you still have 30% not in Terraform. So you will have a lot of noise, a lot of an output to process in driftctl. So if you have a lot of unmanaged resources, or even if you have only one, in the example I show here, you have only the first IAM user you need to create, which is the Terraform user. This one cannot be in Terraform because it's creating the Terraform IAM user. So basically you can add it to the drift ignore. It's pretty much like the git ignore file, git ignore that you already know. It takes like a resource type, AWS IAM user, and a name or an ID depending on the case, and it's gonna be ignored from now on. So until you do whatever you want after that. So if you want to fix the issue, if you want to integrate it in Terraform, if you want to, I don't know, just remove it because it's not something to use. But you can do it at your own pace. So what I do as well is I integrate. I start from the Docker image from driftctl, and I just add this drift ignore file in it, so I can have my own driftctl a binary running with an always up-to-date drift ignore on CI, so every hour or so I have this running. It's quite cool. Speaking of CI, integration is that I think that once you have your initial reports cleaned, I think you should deploy such a tool like driftctl in your CI pipeline, at least as a recurring task, a cron job or however you call it, like running like every hour or so, even if a small subset of resources. So the goal here is to get alerts when something goes wrong, in the hour. So if someone opens up your security group, you want to know about it, and it has to be compared to what you thought it was expected. Sorry. So I've seen different use cases in pipelines, deployment pipelines, people using drift control to ensure, I don't know how it is on your case, but sometimes a lot of people are using scripts and stuff done after the last Terraform apply in the pipeline. And sometimes those scripts create, a mess or something. And so people want to ensure that the deployment was okay after all those scripts were executed in the pipeline. We've seen as well the other way around, like ensure the situation is perfectly under control before doing anything with Terraform at the beginning of the pipeline. Like, I don't know, like a safety check before anything is changed by Terraform apply, during a merge or something. So, driftctl, it's written in Go, it's Apache license, we have support for AWS and GitHub right now as providers. More is to come. Please upvote on GitHub. We have a lot of discussions ongoing here. You can upvote for the Nextcloud. This is completely a community-driven project. Please upvote for the next cloud provider we will support. It's the same for the resources. We choose them based on feedback. So yeah, please do it. We also definitely leave on Discord. So please join us. It's on driftctl.com/d. It will send you directly to our Discord. Talk to us, work with us if you want. We have a lot of contribution as well. So we will be very happy to see you on our community Discord. So basically, if you joined during the talk and you don't know what I'm talking about, the thing to remember is that basically almost everyone experienced infrastructure drift recently. It's perfectly common. And basically that we built driftctl, as an open source tool to help increase the knowledge and security of automated cloud infrastructure. So thank you for your attention. Thanks for watching, and see you soon. Thank you. Bye-bye.